We have already stated the drawbacks of delta modulation. There are two drawbacks. One is the slope overload distortion, another is the granular noise. And to recover from these two problems, we said earlier that we have to use a technique called adaptive delta modulation. So this adaptive delta modulation, short form call it as ADM. This is almost identical to the delta modulation. The only difference is the step size of the integrator can be varied according to some certain logic. So the circuit of delta modulation and adaptive delta modulation may be almost identical, with addition of a special circuit, and we can call it as it is a step size controller. So let us, instead of going to the details of that DM circuit, this is the comparator, this is M, this was the switch, this was the integrator, this was the original circuit for delta modulator. But here this is the switches. Here the new thing is a step size control. So it is a extra circuit that we have to add, and that extra output of this special circuit will be given to the integrator, so that the integrator may change its step size. So, and obviously if there is a step size controller in the transmitter, then obviously there will be similar kind of a circuit that must be present at the receiver also. So that means this is the circuit for the delta modulator, demodulator rather. So here we will use the identical step size control. Similar type of step size control circuit that will control the integrator steps. So what should be the logic? Well, there may be different logic, but thing is that from our analysis with the delta modulator, we have seen that by observing this dqk, we can get an idea what is the value or how the MT is changing. That means if we get successive positive spikes, that means this MT is increasing. Similarly, if we get successive negative spikes, that means MT is decreasing. And if we get alternate spikes, that means MT is almost flat. So from that we can have some idea how the step size can be controlled. But how it will be controlled, that's a different issue, and lot of logic are there, like space shuttle logic. So these are the different logics are there. But step size control actually collects this dqk and it observes whether the previous bit, previous sample and the current sample are in the same direction or not, and depending on that it tells the integrator to change its step size. That means it gives the signal so that integrator step size is changed. So this is how it works. And since everything is controlled automatically, so when MT is increasing at a fast rate, then we will get successive spikes like this, and the step size will be increased, so that the integrator output will reach the actual signal at a faster rate. So this is how the step size will vary. Similarly, when the MT is flatter like this, so under this condition, this D will be something like this, maybe successive spikes with alternate spikes of positive and negative values. So under this condition, whenever we will see that we have change in polarity of the successively received dqk, then we can send the signal to the integrator that you can reduce the step size so that the granular noise becomes smaller like this. So in this way we can control the step size of the integrator to get rid of both the problems associated with the delta modulator, the stroke overload distortion and the granular noise.